Hello everyone, and in the last video we calculated the mean return month by month for both the stock and bond market, and today we're going to complete our mean first of all on the overall stock and the bond market. So we did averages for month by month, our mean return, and now we're going to calculate it in general to find out the mean. So actually we use the same formula, we just equal sign the average and the numerical average value of a data set, ignoring task. And now we go back to our stock, and you can see the formula still stick right here. It's pretty functional, pretty useful in Google Sheet. And what we do is pretty easy. Just drag all the cells, until here, which is cell. If you don't want to drag it, you can just copy from here. Copy from my screen. It is basically H328,109. And now we close a bracket, just do a return. And now you can see our return for the bond market, and it is a stock market, and overall our return is 1.09%. And now let's do the same for the bond market. We do a equal sign average, same again, and we'll do not do the same thing, so we'll basically just change this to bond. It's pretty easy. You don't have to actually go back again. You can just, you see the before the exclamation mark, you just have to indicate what Google Sheet are you referring to this particular formula. And if you type bond, it'll give you the data, which is 0.63%. So this right away just corresponds to what I explained in the last video. I've talked about that the stock market has more risks compared to the bond market, because in bond market you have lesser return, lesser risk, since it's a borrowing money and usually it's issued by the government. Government usually are capable of paying the bond back. You have the treasury, the national budget. And in the stock market, it especially issued by these private enterprises, private companies that went through IPO. So it's much more riskier to invest in the stock market. That's why we try to diversify. And now we're going to calculate the variance. So maybe you guys know about variance, maybe not, but I hope you guys, if you guys are high school student now looking at this project right here, you guys should understand what is the standard deviation. So standard deviation is basically calculating how far away are this data set away from the mean. So it is basically a measure of risk. So today we're just going to say this is a risk. In the finance study, in investment banking, in finance analytics, standard deviation is a pretty commonly used concept in when calculating the risk. Variance is actually pretty the same thing as standard deviation, but standard deviation is basically the square root of variance. So after you get the variance, you just square root it using a Google Sheet, using MS Excel, and you will be able to get a standard deviation right away. So why do we prefer standard deviation over variance? I will also want to talk about in this video, because first of all, we have to punish the outlier. So the difference between why do we apply standard deviation, why do we apply variance? First of all, I want to give you guys a formula. I want you guys to first understand about the formula. So here you're looking at the formula for variance. So the formula for variance is this. So when X is your data and this is actually called a mu. So you don't have to care about the name of this is called a mu. It use as a Greek letter. So X minus mu actually gives you how far away is this data from the average. So if the average mean return is 1.5%, and today my return is 3%, and X minus mu is 1.5%, and then we power up, we square this data, and we divide by n, which is number of data. So this is our data for variance. And if we go to the standard deviation formula, let's make our standard deviation formula. The difference is basically we try to square root it. So it may be, so after square root it, we can actually punish the outlier because we can see more clear. And after square root it, we also will be capable of seeing more kind of applicative data, because if we don't square root this, we are kind of unable to get a percentage. So on variance, so we actually apply standard deviation way more than variance in financial studies. Also, if you guys learn about statistics, I'm not pretty expert in statistics, but I heard it also learned a bit that in statistics we apply more standard deviation rather than variance as well. So that's pretty much about that. And today you're going to use mean for return and standard deviation for risks. And now we're going to calculate the variance. To calculate the variance, our formula is pretty straightforward. We don't have to actually know about the formula. I've talked about the formulas can be pretty difficult to calculate manually, because you have to do data by data to see how far away each of this is from the average, how far away each data X is from the mu, from the average. So we can just use the variance formula given right here, given by Google Sheet. And what do we do here is we actually go back again. we go back to our data for the stock. I'm gonna shorten this up. Oh no, man. Okay, so shorten this. Okay, doesn't matter. I'll just type manually, by the way. So stock, we can H3 to 109. So now pretty much we get our variance. Now we are try to use this part here to reduce our decimal places. Reduce our decimal place. And I actually want to convert this into a percentage. You can actually convert this to a percentage if you want. I'm going to do this. So we'll just keep 5 decimal places and let's keep it a percentage. So our variance now is 0.12%. And for standard deviation, the Google Sheet does this square root test for you. You just have to do this SQRT positive square root, and you just do this. Boom, that's it. And you make a percentage. Yeah. Wait a while. Sorry for that. So now you just lower this up. Lower this. Let's keep it 5 decimal place. It doesn't matter. Okay, it'll be 3.44%. So you can see it's pretty different in terms of this between these two data, pretty much different. And say what I just convert to decimal place. Wait, well, so it's pretty much different. 109, we got 0.12, and let's just do the variance first for the bond as well. Okay, this is what I want to do. For standard deviation, we'll do it a bit later. I actually want to show you a formula. That's what I'm doing. Is the standard deviation formula. I've told you guys that the square root of VAR is standard deviation, but I just deleted that just now because I want to show you the formula right here, in case you have to calculate this independently without the variance. And let's just do the same thing. We don't have to go back to our sheet. We just do here 109. Yeah, we get this. And let's do the sensing again. Sorry, it should be here. 0.99%, and let's make a percentage form. And let's do the same for the variance. Also stand for the bond, STGV, bond, exclamation mark, H3 to 109. Yeah, that's it. So if you compare these two, you can also see the standard deviation has more rates as well. You might be concerned about why the difference is pretty big between standard deviation and variance, but it doesn't matter because when you compare, you only compare within these two. So if you compare independently, it works the same. The risk is higher in a stock compared to the bond, either no matter you're using standard deviation or no matter you use variance. So you will get different number, but you definitely will get the same result on which one is more riskier than the other. And now we have to calculate the Sharpe ratio. Sharpe ratio, what does it calculate? Calculate the risk-adjusted return. So risk-adjusted return is how much return can you get given a amount of risks. So for example, so I've shown you the Sharpe formula. You can also read more in Investopedia on this Sharpe definition. The definition is pretty good in Investopedia. So pretty straightforward. So the formula is actually RP, the return on this portfolio, which is our mean return, RP minus our risk-free rate. So risk-free rate is the rate of return in an investment that has zero risk, which will basically use American Treasury bill, US Treasury bill, which we refer as the T-bill. And we divide our denominator right here is the standard deviation of the portfolio. So we have to calculate our standard deviation. So we made it pretty easy for our calculation. And let's just do it right away. And for this risk-free rate, you have a different option. But everybody basically uses either a bond issued by the government in your country. But if we are now focusing on the United States market, we tend to use a result from actually our US Treasury, which we call the T-bill. It's a US Treasury bill, and we'll apply this Treasury bill for today. This is a bill that the US government issued to the citizens to borrow money for government spending, and they actually return, and there's no risk involved. So if I gave $1,000 to the US federal government, and the government will basically return 1% if they promise me 1%. So it's pretty, that's why I'm applying to a risk-free rate. So let's calculate the Sharpe model. So we have our mean return right here. then you please manually type this 0.19%. So this is our risk-free rate from our US Treasury bill, but this is a long time ago because I want to correspond that to the data I got 2011. So definitely if you are investing yourself, you also want to calculate this Sharpe ratio, the Sharpe ratio. You will definitely choose more carefully, choose an up-to-date or choose like a last 1 year, last 5 years, the Treasury bill average, because risk-free rate can be also different. It can be pretty much different because some maybe today the higher than before, maybe today is lower than before. It can affect on how much return you can get in different markets. So please use a risk-free rate carefully. But definitely, if it's the same, we can actually. But definitely, it doesn't matter too much as well since we're keeping it constant. So even if it's 0.2%, we can still figure it out which portfolio better, but different. But if you have a higher risk-free rate, it means your return will be less when you subtract mean to this, so it'll be a bit different. Okay. So let's now continue with our thing. So 0.9%, let's bracket it up. Bracket it up, and now we divide by what I talked about just now. It's 0.26215. Should we put in percentage? I'm not really think I should. I'll just keep it in the decimal place. If you want to get percentage, just do this side here. But it's a bit confusing when you do percentage, so I'll just keep it in 5 decimal place. Do the same thing for the bond market. Return risks over risk-free rate 0.19%, and bracket it up, close bracket, divide by the standard deviation. Boom, you get a 60%. Oh man, why is it percentage? I didn't want it to be percentage, by the way. How do I convert it to the number? So 0.1629. Okay, that's it. We'll just keep it like this. And I'll decrease 1 decimal place for this. So kind of keep it equal. And now we have the Sharpe ratio. So this is basically what we'll do for this video. And in the next video, we'll calculate the covariance, correlation. And we're going to start off building our project. So I'll see you in the next session.